Yeah. I used to speak very softly, so maybe sometimes somebody needs to remind me to shout a bit. So what are we going to talk about? I saw I have such a large slot of time that I'm not really used to deal with a short presentation of a single technology. So I'm also going to give a short update of what's going on in Hibernate overall, not just in Hibernate Search. Then I need to usually explain why full text and what kind of problems can it solve in a general application. And then we're going to actually talk about Hibernate Search and how it helps you to use Hibernate Search in applications using Hibernate. So first I'll introduce myself. I work on the engineering team in Hibernate at JBoss, of course. I'm leading the Hibernate Search project, but I also work on Hibernate OGM, a bit of Hibernate ORM, especially around the new query parser we're working on, a bit of performance improvements. I contribute a bit to Infinispan, mostly because, as we will see during the presentation, we are using it. Infinispan is using some components from Hibernate, and there are several type integrations. And yeah, Infinispan also uses Lucene via technology from Hibernate Search itself. So there are many integrations. Also, we are in the same division, so we know each other very well. We interact a lot. So about Hibernate generally, what's going on in Hibernate ORM? There's just one slide, but we're working on Hibernate 5. It should not take too long yet. It's probably a matter of some months. There are no really big new user-facing features that you're going to look for as a user. There are lots of internal refactorings and improvements. Of course, one of the goals that we're having is all the time is improving performance, but that's a very gradual and very long process that is very iterative. There's going to be some work which you might see about Yandex. Yandex is a library which was started initially into JBoss 7. It's part in WildFly, and it's the main framework which does annotation scanning around in your class path. It's one of the components which allows the application server to be pretty fast and efficient when it comes to manage all these different frameworks. But this is not yet integrated in Hibernate. So Hibernate is still using its own old style annotation scanning. What does it mean for you? Two things essentially. One is annotation scanning will be extremely fast, especially in the application server, because all the metadata about the model is going to be provided in a very efficient and compact structure. Less memory to be used. And also, this new strategy of annotation scanning looks at the bytecode in classes. It doesn't use the reflection API of Java, so it will not initialize all the classes which are not necessarily initialized, so it simplifies a lot of class loading and initialization in the boot order. One part which you might be interested in is meta model work. So all of what we do internally to represent how the structure of the domain model is managed. That's being extensively refactored. Not all of that is coming in this release of Hibernate 5. That was the initial plan, but we were seeing that this 5 release was never coming, so we decided to aim for some smaller targets. But that might be interesting as well, especially if you're doing pretty advanced integrations and you want to couple in the internals and see how the model is being defined. Something that we're also working on, which affects Hibernate ORM itself, is a completely new query parser. So the HQL language is being, the way it's being parsed and the way the queries are being built is being completely redesigned. I actually started working on that 3 years ago. I'm not working on that full time, so it's also going slowly, but it's already being used in Hibernate OGM, for example. One of the goals of the new query parser is to be able to actually understand the semantics and the goal of a query, so that we can then plug in an engine to be much smarter in dealing with specific features that your database is exposing, so that you can, for example, do some computation to a smarter execution plan for a query, and also all the specific things that now you can customize a lot of details using the dialect. But if you're reading or ever look at how the custom dialects work, they just define small snippets of strings, which then are basically concatenated together to form to build the full queries. When we'll have these parts, the goal is actually that the dialects will not just provide small tokens, but will be able to completely redefine the structure of the query. So things like sort operations can be defined in different databases, complete different syntaxes. And so having a parser like that, we will be able to foresee or tune so that a specific query will perform better than a specific engine depending on what the capabilities. This is not really global parser, which is quite helpful. Hibernate validator is also quite stable, not really much news to talk about. There is going to be, of course, some work with the specification group, because being validation, Hibernate validation is the reference implementation, and we are leading the specification. One of the interesting things going on right now is improved support for Java 8. So Java 8 allows to position annotations in many new interesting places that were not possible before. It also provides new types, like new date and time types. So this is now work in progress, and if you want to join this specific subject, you can join us right now. We're working and tinkering on this area. Hibernate OGM is not quite at all. This is very big news for us. We released the first stable version right now in December, just in time before holidays. For those who never heard of Hibernate OGM, it's a pretty heavy big extension for Hibernate ORM, which makes it possible to store your whole model into any kind of NoSQL store rather than using a traditional database. At this time, we don't support, and we probably never support all the NoSQL stores, but at this time it's supporting MongoDB, Neo4j, CouchDB, Infinispan, and Ahcache. Lots of people are working with interest for the Cassandra storage. The ones we picked were chosen so that we have an example of a TDAM store, an example of a document-based store, an example of graph store, so that we can basically test the flexibility of the engine and see early on what the limitations might be of such an engine. We thought we would fail sooner, but actually we proved it's matching quite nicely for all these different models. And so it's getting a bit of excitement, and we got a huge spike of downloads. We have been pushing some alphas and betas for a long time, but this in December was now the first ever release that we tagged as final and saying, well, this is probably stable enough that we could actually be using it somehow. There are many limitations, of course. For example, many of these data stores don't have a query engine, which means we will not be able to run queries on them. But the project proposes some alternatives for that, and that's one of the reasons for us to have these alternative parsers, so that the parser can actually render native queries for these alternative engines. For example, it's able to parse a subset of HQL. It's not supporting the full language yet, but it's able to transform several queries into native MongoDB queries or Neo4j queries. Well, is it right, Neo4j? Yeah, okay. He works on that. So pretty much a good deal of the team is focused on this area now, and we will probably expect most of the features coming in the area of OGM, which is also very related to Hibernate Search, the topic of today's talk, because Hibernate Search essentially provides an additional way to query your data set, especially when it was designed on top of a database. It would be one additional way on top of the relational queries. In case of OGM, sometimes it's your only way to query your data, so it's becoming a more critical component in such an architecture. Hibernate Search. The big news is we just released 5.0. It took more than a year of time to work on that, plus I would say another half year just planning and deciding exactly how we do these features. There are not many user-facing features, but there is a lot of internal refactorings, and that's I will get back to this topic after that to explain what actually Hibernate Search is and what kind of problems it's solving. So first we start from what is the search problem. So what kind of, in which case would you need an engine like this? So the search problem on itself is that when some user is searching for someone, for something in your database, he most often doesn't know exactly what he is searching for. So it would be quite pointless to ask, let's say, in a user interface. Let's say you have a customer and you're having a retail website which is selling books or other items. If the first user interface you were asking the user, give me the primary key of the object you want to buy, the user will never know, right? He has really no clue of how your system is working or how your data is structured. So this search problem is very relevant when you're building anything which has interaction with humans. So user interfaces in general. If you look at all the modern successful web pages, they're all text-centric. They will all have like a nice search bar somewhere. Just well, Google is the biggest example, but even if you go to other successful websites, like you go to amazon.co.uk, you will see some nice pictures, but the main focus is on the query bar right there, so that you can type and tell the website what do you want. And then from there you can start dialogue, you can start suggesting some things that might be useful. So this dialogue gets pretty complex quickly. So let's start with a very simple model. This is the big, super simplified Hibernate model. Does everybody know how Hibernate model works in the basics? I could explain something. Let's not waste time. Okay, so let's assume we have, in this example, this is coming from one of the examples you can download from the Slim website, which includes Hibernate Search. One of these examples makes a website for selling DVDs. So you have products, you have DVDs and Blu-rays and other things, and you have actors which are so in every product you will have a set of actors. So we have just two entities to keep it very simple and one relation. Of course, what must matter the most is probably the title field. It's the name of the DVD that somebody might want to buy. But what matters to your internal infrastructure is the ID, which is how you uniquely identify this object that you might have a transaction. The actor itself is probably not very interesting for your business, but the user might also be searching by actors. You might do some suggestions about that, so it's part of your development. So if you have, well, we can all guess how the tables will look like in your database. So let's say that you want to build this shop, and you want to allow people to search for titles or actor names, so that they find what you're looking for. Try to match what the user has given you, and maybe also match actors to see if the actor that he has typed is actually one of your actors. But there are so many terrible limitations with this one. Well, the first big problem is, of course, the user will have needed to have typed your product name exactly as you have it. If you have one abbreviation or one typo, or just the case is different, or maybe you're looking for the matrix, but you type it matrix, and it will not match, or one abbreviation in the name of the actor that you have in the database. So your result will be empty, and your shop will tell the user, well, we don't have that product, go buy somewhere else. It's really not right. you would like as a website. So you can try improving a bit. You can like deal with the case problem, just lowercase everything and standardize and tell all your developers we are going to store everything lowercase in a database. You have to lowercase the inputs and match at that level. Solving a little problem, but you're not getting very far, right? Because, well, people will also have like accents, and some people will not type the accents on the name. Or you can have like the same author might be written in different ways, or there are really apparently canonical standard ways for people to write that. But you will get more and more requirements coming, which make it so complex that SQL will really not fly. For example, yeah, the multiple terms problem. If we use it as wildcard and prefix and postfix, that's not enough for wildcards in between. Right? So you need to chunk the text and start looking at parts of text and see if some parts are matching parts of the database. This is going to be a very expensive query also in your database if it's not a very small data set. But the biggest problem is the relevance. So you don't want to just show a list of things which exactly match what the user is looking for. You need to, you're starting a dialogue with him and you try to guess what is he wanting. And you might have multiple proposals, but some of them will be much closer to what he's wanting than others. And your results should put this top so that the user will probably be lucky and find what he needs there. And as we learned from Google, people don't really want to put data in different field texts. So if you are building a website and you're asking for author and title in different fields, in a more complex realistic domain, you will probably have a big form with lots of different input boxes. And people will need to fill all their in just to find something. They will be running away so quickly. So what people want is a single input box. And from there, you need to guess exactly or very close to what he wants. And you have to be very fast to search for multiple fields. For example, here, Google is showing for this simple query, oh yeah, I found 80,000 results. It took me 0 to 4 seconds, which I think I took this screenshot some time ago, they probably improved a lot. And these on top here are what I think you are needing, because you are definitely not going to browse across 18,800 results, especially if the results were returning, let's say, order by price or in alphabetical order. It doesn't make any sense for trying to match the user interaction. So what you need is implement similarity. For example, people might have heard of Hibernate but have never seen it written, so they heard of it in a pub. Some people were suggesting to use it, and then they type it. They might type it wrong, but still, if your engine is quite smart, it will be able to suggest, or maybe you meant this thing here, because we can do a bit of computation on the term itself, but it gets much more interesting when we are composing multiple terms, because then it can guess that maybe all from this context or from the other terms that were put in the query, you probably meant Hibernate written in this type. And of course, you want to be able to support synonyms, or also to say what's more valuable in kind of query. Yeah. So of course, if Google were really going to return all those results in alphabetical order, it would be completely fine. So nobody would use it. So those biggest money-making corporations there would really not exist. So I think it's pretty clear now that we cannot really do this in database. You can try to emulate, like I've seen people building tables in which they will put, there is a column in which they will say term, and that's like one term of like a tag that they have associated with a description of some of their items, and then each of their items are connected to a list, like with a join table to a list of these tags. And then they need to load all these tags in memory and iterate through all of them, doing statistics, like how many of these are matching. Well, that's exactly what Lucene is doing, but in a much more efficient way. So that's what we want to do, and you really don't want to put that burden in the database, because it's not really meant to do that. So that's where we start talking about Apache Lucene. Lucene is a Java project, open source of course, hosted by Apache. It's one of the top most active projects in Apache consistently since many years. I think it's now more than 10 years. It's there at the top as well. Having the most activity on mailing list, the most commits, the most fixes, the most contributors and committers. So it's very solid because this very critical mass of people have been working on for many years on it now. Well, it's mainly Java, but then people, sub parts of this large community is ported to other languages. So, you know, there's a Python version, there is a C version, and there is a .NET version. And it's also used by many companies and many products. Like the big one nowadays is Twitter. Every time you search something on Twitter, you're using search via Lucene. Every time you're searching for bugs in our issue trackers, that's Lucene as well. Alfresco, LinkedIn, every time you search in LinkedIn, it's Lucene. So it has pretty much proven itself, and it works at scale, and it works pretty efficiently. So what does Lucene gives us? It gives us this concept of similarity. Given a text that the user is giving you, is that similar or close enough to some of the descriptions or texts or multiple fields of your structured data, and is able to compute that efficiently and narrow down, this is the subset of things that you should suggest, this is the order. You can define your own synonyms, you can define stemming. Stemming means that you're going to narrow down every term to the root, and that helps you building a better matching in the language. It does that, we'll see it later. Stop words. Stop words is another technique that is mostly meant to boost your the performance of the scene itself, and also, let's say, work around corner cases that otherwise wouldn't work too well. What stop words means is basically which parts of speech in a sentence should I completely ignore. And all of these parts in Lucene are completely configurable. So there you have a big advantage compared to closed box like search engines. For example, several years ago, Google announced this the Google appliance thing that you buy. It's a server that you plug it into your enterprise, and it will start searching on the internet, and people can search in that. It seems it did pretty okay, but it was a bit fiasco in many areas because it's completely closed and sealed. We cannot really configure it because obviously they did a pretty good average, like good settings that would work in many cases. But what you really are after in this field is to be able to define the synonyms which matter for your specific domain model. So if you are building an application which is in healthcare, you might have lots of very specific terms, or even some terms which are very specific to your application or the specific field in which your thing is being deployed. And you can control all these things in a very fine-grained way. Now, where it gets a bit tricky is that with all these control points, it's sometimes a bit complex to get to that point. What we are trying here is to make it very simple to get started and to take out some of these complexities and move them into declarative ways so that you can change and experiment with multiple approaches in big operations. Okay, and the similarity is worth another couple of words. So how does it compute how similar one block of text is to another block of text? Well, it has to split this text and process it in multiple tokens. How these tokens are split, that's up to you. There are many standard analyzers, they're called, so you can pick from a pretty extensive set of analyzers, but all of these analyzers come with also very nice defaults. So you can pretty much say, okay, this is just English language, pick the, from the shelf one good which is pretty much tuned for English language and that's it. Or you can go more in depth and tune, okay, yes, it's English, but I want you to also apply these additional transformations to the text. For example, you might want to be case insensitive rather than case sensitive in application. It's a very simple option that you might need. Or you might have some fields which are in English, some other fields which are in French. You could use a generic analyzer which just does lowercasing and split and white space, but will work for everything pretty much okay. But you can get better results if you specialize it, so you can actually tell it what kind of language to expect and how to process each of these fields. For example, phonetic means that you're going to encode all the text in how it's meant to be pronounced in English. So you will have a better result if you have to match things that people have heard rather than what people have seen written. Well, it's all up to you. The good news is that there is a very extensive ecosystem of contributors who have dealt with most of these elements already. Synonyms. Synonyms will require vocabulary, of course. So when it's processing your input text, you can tell it basically every time you see this token, you have to replace it with this other token. So you're normalizing multiple variations into one canonical representation, which is the symbol that you want to use in the index for that specific set of words. It's a bit tricky sometimes. You might want to play in the direction of synonyms. Like in linguistics, the synonym means that two terms are completely replaceable in two directions most of the time. That's what people use with this term. But in practice, sometimes the direction is only in one way. So you can play with that kind of effects. For example, you could say that a newspaper is a journal, but sometimes it might not be correct to say that a journal is a newspaper. Definitions of what you define to be a synonym, and so you can also do, for example, extensions of acronyms. Acronyms which are pretty much known in your specific domain. So again, if you are deploying an application for healthcare and all your doctors are referring to something specifically, let's say NHS, you can expand that to something which has a broader meaning. Well, this is the example of stemming. It's about, so under the hoods, after we have processed all this text, what matters will be exact match across terms after the processing has been done. So what you have to do is to make sure that you are chunking your input text, lowercasing, and making keywords out of them. But these keywords need to be matching exactly. So for example, if you want to have these words to match so that if you have like continuate, this is French, continuate in your input text and your description is having continue. If you want this to consider this a relatively good match, then you should use stemming so that it will chunk off the last part of the word. And luckily, there are stemmers for more than 400 languages including Lucene, so you can get started pretty quickly. And there are stemmers for different variations of Chinese and different variations of Japanese. And if you don't know them as a programmer, it's going to be a problem because the rules are very odd. But that gives you much better matching in the precision between the things that you're looking for and the input of the user, so that what he is looking for will actually be on the results. Stop words are already mentioned, things that you want to remove out of it. This is an example, this is the list of the stop words that people normally use in English language. So these terms, they're not really meaningful. If somebody is searching for a sentence, and it types the whole sentence, and in this sentence you have an after, almost, or something, you will ignore that when you're doing a match with your products. So all these tricks, they're also meaning to reduce the set of keywords that you have in your index, which keeps the size of your index small, which keeps the performance of the system quite high. But there is a catch. So where do you store all these structures? So that's called the Lucene index, and it's not going to be in your database. So in terms of operations, when it comes to apply this technology, who runs your servers might probably hate you because you're coming up with a completely new requirement. And you're saying, okay, first we are storing all data in the database, the application and the application server. Now you need an additional storage system, which is where do I store the index? Now, most of the time it's perfectly fine to store it in a file system because Lucene is very heavily optimized to make efficient use of student lists or just big files like this. You can use memory. You can use Infinispan. A couple of more words for that later. But essentially, these are large chunks of bytes arrays, which represent the tree structure which needs to be iterated by Lucene when you're running a query. These can get quite large. So people get indexes of 100 gigabytes. But the good news is they will never get as large as your database. And the growth, since it's in keywords, the keywords are unique in the representation of the index. And there is only a limited set of users. So at some point, your database will double size, and your index will grow by 1%. And then you double the size of your data again, and your index will just grow another 0.05%, because at some point you'll have most of the keywords already defined in there. And for each keyword, it just needs to add some little references which point to different areas of your database. So, other catches that you need to consider is this index is not all relational. So we cannot do complex join queries on top of this, and we cannot represent relations in the index. This is a big catch and makes it a bit complex to work with the index sometimes. And the big one that we focus on is you need to keep these indexes that you're having in sync with changes that you do on your database. Then how do you run queries in this thing? These queries are very different than what you run on SQL, and the results are very different because the results will not be the database itself, it will be identifiers with pointers in there. Yeah, what do you do with that? You do that some other data. That is okay, so since it's not a relational work, in the object work we might have a representation like that. We have this DB store, which has this relation with factors. In the index world, this needs to be denormalized. So we will know from the university that we can normalize in first form, second form, third form. We can normalize database in many ways. People normally want to use third form. In the index world, everything has to be denormalized, so you get this copy out of there. Which means some information is lost. You cannot really restore the whole domain of the out of the index. So the index is really just an auxiliary to your main database to run certain forms of queries. It's not your primary storage. And you have to deal with those things, which is another catch, of course. And that's where Hibernate Search comes into play. What we do here, really, how do you get started with Hibernate Search? So its goal is to solve these mismatches that we have just seen. What you need to do to get started, the first thing is you need to add a dependency. So this is the latest main identifier for the latest release that we did in December. All all you need to do really is to add a dependency. You don't need to register things in Hibernate anymore. The configuration in Hibernate is pretty much untouched. There are some additional things that you might want to do first, because there is a lot of tuning that you can do. We have all these advanced language processing options that we mentioned. And there are clustering options, which are also a bit different on how you would cluster on a database. But essentially, all these areas are optional. So all you need to do is add the matching version of Hibernate Search to your application that is already using either Hibernate or GPA via Hibernate. And then you have to add some additional annotations on top of your domain. So let's take this essay entity. This is just having standard JPA annotations. So we make it an entity. It has an ID, then you have some text and a relation. The entities you want to be managed by Hibernate Search as well, they need to be indexed. So you have to opt in which of your entities in your domain model will be indexed. In most cases, it's just going to be a subset. I've seen complex domains of 600 and more different types, but then like 3 of those need to be indexed because that's what people actually search for. And then the rest is like storage. So you say essay needs to be indexed, and then you need to say which fields do you want to be searched for. That's this field. And there are some additional annotations like the boost option. In this case, boost takes float, which is going to slightly rise or lower the importance of this field compared to other fields. So if we do this thing here, you'll have a summary and a text. Let's say you have the single input in the web page where your user will be able to type something. What we do here is basically, if what the user is typing matches the summary, it's going to be considered more valuable than if the user is matching the description. So if the user is searching for your DVD, Batman, something, some titles might match, but in some other cases you might have a film which has a description, a movie, which is saying like this is similar to Batman or something. So that will be included in the result as well, but the ones which have the title matching will be classified higher. Now I'm just doing an example with a single term. Again, the result is interesting when it comes to the composition of multiple terms. People will type multiple terms in the input text, and you're going to combine the floating parts of this. That's what the engine does. So the boost is just an example of how you can tune the different precision of the scoring system. And then, since it's denormalized, there is this annotation indexed embedded, which means we are indexing essays. So what we are going to search for in our engine is entities of type essay. But we will also want to include in the same index for essays properties which are actually defined in these relations. So yeah, let's say that author has names as well. It means that in the essay index we will have multiple fields of author name included, so that you can search by author of all of them. That doesn't mean that we're creating an index for author. You can do that as well. You have to explicitly opt in the author entity with an index as well. So how do you query that? First thing, you need a full text variation of the entity manager or the Hibernate session. So we have a full text entity manager, or you can have a full text session if you're preferring to use the Hibernate API. And you use this little helper search, get full text entity manager, you pass it any entity manager. The return of that is again an entity manager, but this interface defines some additional methods, which are those which allow you to do the full text queries. And then, you define the Lucene query, which is and then you wrap this Lucene query and you tell it which entities are you looking for, which types. Because our engine The Hibernate model is focused on specific types in the domain. And the results of that is pretty much the same. So the full text query is an extension of the query API, so you can add the user paginations and get result list methods. In addition of that, it has also a get result size, which will return you the total amount of results that the query is matching on your database. So in the example of Google, which is going to tell you, okay, I matched 18,000 results for this query, you'll have the 18,000 out of there without actually needing to load 80,000 products in your list. So in this case, we'll have 100 or less, if there are less matches, results in a product list, but the number in total might be higher, so you can easily make an interface which provides pagination without loading all the information. So how do we create this Lucene query? I didn't omit it here. But how you create a Lucene query? There are two ways. One is you just use the Lucene API. We completely expose that, fully transparent. I don't really like to hide all what Lucene is able to provide you. So here, this type, this is actually org.apache.lucene.query. You can create that object in any way you like, using any of the libraries of Apache Lucene, and you just pass it to Hibernate and it will match the managed entities. Or, if you don't really like to study all of the Lucene query capabilities, which are pretty advanced, but also maybe a bit scary because there are so many options initially, you can use our query builder, which makes it a little easier with the DSL to perform most of the common queries that you might want. You get the query builder from the full text session. Again, it's strongly typed, so you have to get the query builder which aims at a specific type. And then you use it to create a query. Keyword style search on the field name, and also the other field method, because we're going to match multiple things. And we want to match, this is what the user is typing. What's going to match that? There you create the query, and then you throw it in there and get the results out. There is one more very nice side effect of all this, which the entities which are loaded in the list are actually loaded in the same transaction of Hibernate from the database, and they're fully managed. So if you do any kind of change on these products which are loaded, they will, at the transaction commit, they will be applied again on the database and on the index as well, because we are keeping both the same. Yeah. In addition to loading the entities, you can also load projections. So you can say, typical example is the Google result page. You won't have really the full pages matching, but you'll have small snippets out of there. So you can load snippets of what your matches were directly from the Lucene index. And in this case, with the projection API, you can specify which fields you want to load and in which order. So there we're not going to return managed entity in this case, but we're going to return arrays like you're doing a projection on a database. Like when you're picking specific columns, that's going to be the same, but in this case we'll be loading results out of the index. And then you support filters. The filter looks approximately like this conceptually. In the index you have arrays of entries. These are organized by document IDs, they're called, so they're all identified by an integer, a number. And so if this is your original index, and then you have a query which is going to select some of those, let's say out of 20 million entries that you have in your index, people run a query from a specific string that is their input, and then you want to filter out some of those results because they shouldn't see this or that for security reasons, age reasons, or just because they enabled some options and checkpoints in your UI. You can stack additional filters on the Why would you add why would you use filters rather than add criteria on your query? Well, because they're declarative, so you can enable, for example, security filter, and it's done with the apply to the whole session in Hibernate, or just for simplicity, but also for performance reasons, because filters can be reused across different queries if they are matched to the same. And they can get you very high performance boost. Of course, only what's remaining out of it will match. This is how you use a filter. So you create a full text query, and then you say, okay, well, but on this one you have to enable the minus filter, which was declared somewhere. And you can have parametric filters. So you can say, okay, but we want to just show the special offers, the special deals for this specific day. And you can say, for example, only the things which are in stock at this specific place, and so it will select sometimes. These kind of filters are very reusable. So if you have, let's say, 3 shops, you will have 3 different filters for each of your shop, and they will be very hot all the time. So it will improve the performance a lot. This is an example for the French analyzer. How you do this in Lucene, I actually forgot, but it's a couple of pages of code to define an analyzer. So pretty nice that we have this declarative way. On top of any indexed entity, you have the analyzer def, you give it a name, and then you specify the stack of transformations that you want to be applied on the specific analyzer. So in this case, I'm going to say, well, just use the standard tokenizer, which is the one which is going to look for white spaces and chunk text over there. And then you apply these filters. I want you to take each of those tokens and lowercase it. And then we apply snowball filter. Snowball is one of these collections which provide a language-specific processing. And so you have to provide it the parameter, which is French. And so we define in our application, that's how we move French analyzers. And you can apply it to specific fields. And also apply it programmatically in case you have fields which are, which vary kind of processing. And there are many more annotations, but I'm not going to bore you with details of each of those. They're all pretty well documented in documentation. So let's focus on some more interesting things. This is an example of faceting. If you go in Amazon and you type Hibernate Search, you will have the main results in the main part of the website. And so on top of it, you'll have a very good match, which is the book about Hibernate Search itself. And then you'll have more results, of course, but the precision in which it's matching your specific queries is going to be lower because they're using full text correctly, of course. They want to sell your stuff. But also, on the left side, you have this area. So it's going to tell you immediately, okay, from all these results that you have, we have 14 in the programming section, we have 4 in computer science, 2 in databases. How expensive do you think it is to compute that when you are running a full text query?
Depends on your object model.
It's completely free because these categories, these are parts of the term. And when it's doing the full text match on this side, the computation it's doing is it's reasoning on terms and frequencies. So having that's actually that's a side effect of the computation that you're doing for the main query. You might as well just show it to the user, and it happens to be very handy. So it's pretty nice. It doesn't cost you anything in terms of compute power, on top of what you already did at this point.
And it improves the usability.
It improves a lot. It's very useful. Lots of websites have some form of faceting on their site. This is, I take Amazon here because I think it's familiar to most of you, but if you look closely at effective websites, they will all have an UI centered on this concept. It's very easy to use faceting with Hibernate Search. You just specify, which of the fields of your domain model should be grouped on. You can specify multiple groups because you can have multiple facets there. And then when you run a faceting query, the result will be different because you're not getting a list of products directly. You're getting a bit of a richer structure so that you can actually so iterate for always. You can do more like these queries. This is a new feature in Hibernate Search 5. It was available in Lucene since a while, but we just didn't have a nice user-friendly API for it. We just introduced this. Conceptually, what does it mean? Is when you're looking at an entity which is packaging these full text indexes, and you said, okay, yes, this is what I want approximately. Do you have more stuff which is similar like this? So in a way, it's like running a query by example. And in Hibernate, the API looks exactly like that. You feed this query an entity or an entity ID, and the query will return you a list of matches that will be closely resemblant to the model that you give it. By default, it will just match all the fields that you have indexed, but you can narrow it down. So, for example, you can say, okay, is something similar to this if you look at just age and title, and then it will look just for those matches. It's very handy as well again for using it. And what we also recently introduced, this was actually new in 4.2 or 4.3 in that area, but it has been experimental for a while. It's considered stable now. Mostly we were in polishing the API. What does it do? It allows you to do very efficient range and distance queries. So it's a kind of numeric query. It's not really focused on tokens anymore, but it also indexes numbers and it's very efficient on ranges. So when you have ranges and you can combine multiple ranges, that means you can do coordinates and it can work. Spatial can actually work in 2 different modes. It will initially narrow down areas in large blocks because it's more efficient. And then it is also going to do like round circles to precise distance calculations. So why is spatial so interesting and you wouldn't use the database? Well, the thing is you cannot combine a full text query with a relational query. But sometimes you're looking for something, again, in form of text. Let's say I want to find a nice Indian restaurant, and you're looking for it. And then your best, recommendation engine is going to suggest you restaurants in New York, or San Francisco, in South America, India. But of course, you want to say, well, but in range of 5 minutes walk. So it's an additional restriction that you very often want to apply on top of a keyword ranges. So you want to combine keywords distances. Well, that's about it in terms of what it does. And then we come to how do we do some other stuff. For example, I mentioned you might need to do clustering. So if this index is stored at disk, and you need to replicate it on multiple nodes because your application server, you have multiple application servers connected to cluster, then you need a solution to replicate the contents of these disks among servers. One of the approaches looks approximately like this. So for every index, you will select one node to be the master node. And from there, you have it like replicate. He is in charge of making bytes on the index, but then these indexes are pushed just via NFS or rsync, something very simple, but you want to set up to do copies to the other slaves. The only thing that you have to set up is that each of the nodes will need to forward changes to the master node. So we have the backend, which can work via JBooks, or the backend which can work via JMS, or you can write your own. It's pretty simple. The serialization stuff is all done for you. So you just have to make sure that you couple the output of the indexing engine of one machine with the input with one of the others. This is very scalable, but pretty good for asynchronous updates only, because of course you're not copying these indexes all the time. In most cases that's okay, because let's get back to the DVD shop example or the Amazon example. You're adding items to your website, but it's not really crucial that the items that you have added to your catalog are available for sale like in the same 5 minutes. Most of these web shops add new things or adjust prices overnight, and all they care about is that people will be able to search them efficiently next day. We have another advantage, which is if these indexes are not playing with online, internal caches in Lucene stay very hot, and the efficiency is very high. So it's generally helpful. But if you want fully synchronous replication of indexes, you can use Infinispan for storage. Infinispan will provide an efficient real-time replication. So every time you write an Infinispan, at the point in which you return from the method, it will be immediately visible to other nodes. There still is one catch. You still need to put this query, this queue in place, because by the way Lucene is designed, you can only have one write at a time. So rather than doing round robin, I write, then you write, and that's the layout writes in turn, that will be a nightmare in terms of locking, and it's not efficient at all in our Infinispan, or sorry, now Lucene batches writes and it buffers. So it's better to have it pick one node who is writing all the time, and all the other nodes delegate to this one. This same technology is also included in Infinispan itself. It's the technology that WildFly and JBoss AP use to replicate your sessions, have caches for Hibernate distributed among application servers, and for some other of its clustering functionality, but it's mostly like internal, so it's not really exposed to end user to use Infinispan, at least in here. Yeah, you can. But,
if you want to direct yourself that cache.
What I meant is in EAP, it's, you're not supposed to use it, so you're not supported. In WildFly, you can do whatever you want because you're not supported anyway. But there is a different product, which is JBoss Database, which gives you full support to actually using Infinispan directly in your application. So I won't spend too much on this. Just wanted to say there are many integrations that we do between Hibernate and Infinispan. So one thing is Infinispan itself uses Hibernate Search. So all what I've shown so far is about integrating Hibernate and how it synchronizes the relational database with the Lucene database. Infinispan does exactly the same, just that when you're writing to the database in memory and you're changing keys in a distributed system, it will also update the index. Optionally, to have them indexed with the same annotations because it's just depending on the same Java library with the same annotations. The mapping is the same, so you use the same field, you use the same boost, you use indexed embedded, all the examples that we're seeing, and all what you learn from using Hibernate Search from Hibernate, you can use exactly the same syntax and API inside of Infinispan to search for entries inside of the database. And then, well, of course, Hibernate, I mentioned, it uses Infinispan as second level cache for its own caching, so it's good to know because Infinispan to do performance tuning. And vice versa, Hibernate Search uses Infinispan to store the indexes as a previous. Where else is used Hibernate Search? It's now included in WildFly. So when I mentioned before, all you have to do, you have to add it on the class path. I was referring to applications in JavaC or in any other environment that you're running. If you're running on WildFly, you don't even have to add dependency because it's there. But you have to enable it. So it's not going to be exposed to your application by default. You have to add one line in your manifest, which is basically triggering the visibility of the class path of Hibernate Search application. The line is defined from the documentation, so it's pretty easy. Cape Dwarf is another project in JBoss. The goal of Cape Dwarf is to give you the Google application engine environment to run in your own data center or on your own machine. So it implements all of the APIs of Google application engine so that you can deploy an application that you're writing, meaning to run it on Google application engine, that you can test it locally or you can deploy it locally in your own environment. Cape Dwarf is built on top of Infinispan and the query capabilities of Hibernate Search as well. And we're getting back to Hibernate OGM again. So as I mentioned before, in case of Hibernate OGM, we have this, it's using this new query parser, so we can understand what the structure of the query, what it looks like, and what the goal is. And this parser is now able to transform this into native queries of different technologies. So, for example, the MongoDB native query and execute those. But on top of that, since many of these storage engines actually don't have any query capability, what you can do is you can add some annotations of Hibernate Search and run queries through that. It also happens to be that it's a bit of a snake biting itself, because, for example, if you use Hibernate OGM on Infinispan is a key value store, so it doesn't have any query capabilities. So you can use Hibernate Search on top of that. But Infinispan does not actually have query capabilities because of Hibernate Search itself is being embedded there. So there are many ways that you can combine these technologies. This is how the project dependencies look like. So the Hibernate Search engine is the core component that we're having. It's a jar which depends on Apache Lucene, of course, and exposes Apache Lucene capabilities. And this is basically an event listener. So it listens to other frameworks which connect to it and say, you know, I've updated this object which looks like this. And it makes sure that all these event updates are applied in a consistent way, maintaining proper order and as efficiently as possible on the scene index, and vice versa to be able to query this structure. Now, Hibernate happens to be able to generate events for anything you do, and you can plug listeners to it. So the Hibernate Search ORM model is nothing more than a set of event listeners which are automatically registered in ORM when they are seen on the class path. And it also adds these additional API sugar methods which make it easier to transform back and forth to Hibernate entities. The Infinispan query does the same thing because Infinispan generates events. So what's happening now is that this Hibernate Search engine is actually being used by other projects as well to generate events and need to store things in AMSync. An example is Shape. Shape is another project in JBoss. It's a JCR implementation, a lot more, but about what the features it does. It also plugs on top of the Hibernate Search engine. And one of the benefits it gets is that from there, it doesn't need to deal with API changes in Lucene, which are pretty massive. Every time they change things, you have to rewrite 4,000 lines of code. And it inherits these clustering capabilities on top of JBoss and Infinispan. So other frameworks are building on top of that. There is now a student in Germany who's doing a thesis, and what he's doing now is going to plug the Hibernate Search engine with a custom set of listeners which are JPA agnostic. So his goal is, we are highly coupled into Hibernate ORM, and there are many technical reasons that we need to do that. He's facing these technical reasons to try to find workarounds so that it can actually work with any kind of JPA provider. It's very challenging, but we're trying to use it to help him, and it's interesting. So you can use the engine independently as well, even if you're not interested in Hibernate ORM. So what's specifically new in Hibernate Search 5? Well, the big news is that it's finally using Apache Lucene Series 4. Now, Lucene had a very good track record of being pretty much, or it's very stable in terms of bug. It doesn't have many bugs, or when any bug is found, they're very good at fixing it very aggressively. But Apache Lucene 4 was really very different than Lucene 3 in terms of APIs. So while lots of our users were begging to move to Lucene 4 because benchmarks were showing up and people were seeing awesome new numbers like, oh, it's 1,000 times faster in a very specific use case. But in some use cases it was much better. In some other use cases it's just exactly the same, so don't get too excited. But many people wanted it, and it took us a long time to do that. I'm actually very satisfied that the result is that our API is pretty much stable. So we didn't have to change much in what users of Hibernate Search have to change when upgrading of Hibernate Search 5. The bad news is that we leak some of the Lucene APIs. For example, when I show the analyzer, you have to specify the fully qualified name of the analyzer class that you want to use. And they renamed all of the 400 analyzers that I have for consistency, cleanup, many good reasons. But we expose some of these details from the scene, and you will be affected by that if you are migrating from Hibernate Search 4 to 5. Another thing is, like I said, we let you specify the Lucene query using Lucene APIs. Well, if you did that, you probably have to rewrite all that code. But from our side, our code, we didn't have to change much. We rationalized a couple of things. For example, the spatial API was considered experimental before, so we have been polishing a bit how exactly the methods are named and those things. So those things are changing. But essentially, I think I found another good reason to use Hibernate Search, which is we try to shield you very conservatively from changes in the underlying engine, which sometimes are quite crazy. We have a higher commitment to stability. Well, another new thing is we have this more like this capability now, and we are working a lot on OSGI. Nobody really cared about OSGI until a couple of years ago, at least in the world I work. Now all of a sudden it's a requirement for integration for many products, so we get requirements from our managers, like this stuff needs to work in SGI by every month, and we say, well, that's not going to work. So we worked a lot with this. We passed all the integration tests that we could figure out so far. Now Gustavo just rising the bug, so I thought we were done, but there's still something missing and I have to have the experimental there. But I think generally if you're using SGI, I'm expecting it to just work fine. If it doesn't, please let us know, because we're just at that line of polishing that we really need to know what's not working or in which cases. Yeah, we test specifically with Apache 2 and 3. Those are the main what else improved us a lot as well is with JBoss models. So the way in which we integrate with other JBoss projects and the way the models are defined in WildFly and EAP, that's improved a lot. You will see much less leaking of classes that we use internally. For example, the serialization for clustering technology uses Apache Argo, which has its own dependencies and so on. Or for sending messages, we might use JMS, but we use it internally. Or we use JGroups. And all of these things which are done internally will not leak to your user application cluster. So you can use your own version of any of these frameworks which are used by Hibernate Search and keep the room of conflict. What's exposed to you is exactly just the annotations, the API of Hibernate Search, and a specific version of Lucene. That's something that we will expose because that's a part of the API contract. An extension point is improved quite a bit. I have one nice example of an extension point. We do a transformation of types. So if you have a string field, before we were making examples like a string author needs to be encoded in the index. So the string author in the index is going to be a string. It's easy. But if you have a date field, or if you have a number field, or any of those other primitives, we have out-of-the-box type transformations for them. So we call them those field bridges. So we can transform a field to a different thing. These are now discovered. So you can plug in custom field bridges bound to your specific types. So if you, in your domain, you like to use your own types frequently and you want them all to be encoded in a specific way, you don't have to annotate each of those instances in your domain model, but you just provide one transformer and make it discoverable with the service loader pattern, and we will load that. One of the reasons we did this is that all of this is requiring Java 7 to run, but we really want to provide also out-of-the-box transformation for Java 8 and ORM types, because we expect a good amount of people to use Java 8, and we want those types to be easily transformed in index as well. So we made this pluggable so that we will be able to compile a separate module which will add support for out-of-the-box transformation of Java 8 types without needing to force everyone to upgrade to Java 8, which is needed. Any specific nice flashing demo, because it's backend technology. So what should I show? But I see pizzas are there. It's pretty late. I have a massive amount of source code with tests in here, from all of WildFly source code, EAP source code, all of Hibernate versions and projects, Infinispan as well. And if you're interested in diving into any of those details, we can just break up parallax and pizza and I can show you some tests directly. Especially if you want to participate in any of these projects, I can show you how to get started, how we just code the process. Yeah, it's pretty easy, but we can show you internals which might be interesting to you. And really, that's all. Just a reminder, these things are included in these products. These are the projects we're working on. Thank you very much.